Okay, so today we'll be talking about the largest hacks of 2023 so far, specifically in the context of their root causes. Now, any protocol that maintains collateral has to ensure that the user's collateral is sufficient to support their debt. And so this is done by calculating a health factor. If this health factor drops too low, then the position can be liquidated. So it's essential for all the appropriate protocol actions to ensure that this check is in place in these functions, or the position will become liquidatable, leading to unexpected states. Unfortunately, some protocols do forget to implement these checks in certain functions, and so far this has led already to a loss of over 206 million this year so far. The largest hack of 2023 so far is still the Euler Finance hack. And the Euler Finance is a lending protocol which supports liquidation, which is very profitable. In fact, a liquidator gets a 20% discount when purchasing the collateral of a liquidated position. Also, Euler Finance has a function called donate to reserves, and this allows the user to donate their collateral to the protocol. Unfortunately, this function was missing a health check at the time of the hack. And so this allowed the attacker to create a liquidatable position at will. And then when they did this, they could immediately self-liquidate, taking advantage of that 20% discount and making a profit at the expense of the protocol. And by repeating this step several times, they were able to drain this protocol. The root cause of the platypus hack, which also happened this year, was very similar. In this case, the protocol was exploited through the emergency withdrawal function, which was lacking this health check in the correct spot. So the protocol did not check the health of the position after deducting the collateral to be withdrawn. And so this allowed the attacker to withdraw as much collateral as they wanted to and essentially steal funds from the protocol. So you can avoid missing health checks by writing tests for all the appropriate functions in the protocol. These tests can attempt to bring the position below the liquidatable threshold, and you should assert in these tests that this attempt should revert or fail. You can also use invariant testing or fuzzing to find specific cases where this threshold can be reached. Most DeFi protocols require some type of configuration, and when misconfigured, this can lead to devastating consequences. Just this year, we've already seen 25 million loss just due to misconfigured markets. Now, one of the first large hacks of 2023 was on the LendHub protocol. LendHub is a compound fork, and it has L tokens instead of C tokens. So what happened here was that there were two LBSV markets. There was the new and current one, and then there was the deprecated one. The new LBSV market referenced the new comptroller, and the old LBSV market referenced the old comptroller. So this allowed the attacker to deposit their collateral in the old market, take a loan from the new market, and then immediately withdraw their collateral from the old market without repaying any of the loan. The root cause of the 100 Finance hack also this year was very similar, and it's also a compound fork. In this case, the comptroller was listing two different HWBTC contracts, the one that was used by normal users of the protocol, and then this duplicate empty market which had been completely unused. And the hacker exploited this to steal funds from the protocol. Here's another type of hack due to a misconfiguration, which happened on Yearn Finance. This is actually a pretty old contract, but the hack happened this year. So the problem here was that instead of listing the fulcrum market for USDT, it listed the fulcrum market for USDC. This allowed the hacker to manipulate the reserves and steal approximately $11 million worth of assets from this contract. Now, market misconfiguration can be prevented by writing tests for your deployment script, and this can be done on a localized mainnet fork before you actually deploy to mainnet. So you should not only assert the correct state of the contract, but you also should have negative test cases, such as checking for these duplicate or empty markets, because as we've seen, they can lead to very serious hacks. And auditing firms can also help to ensure the correctness of this state. Now, some DeFi protocols allow their users to pass in parameters which represent external contracts to be called, and some protocols even let you specify the function to be called on this external contract. When these parameters are not validated, this can lead to some serious hacks, and this has happened several times this year. So a great example is the hack which happened on Dexable. Dexable is a DEX aggregator, and it actually allows the user to specify the contract address of the DEX, as well as the function, the swap function, to call on that DEX. And so what the hacker did in this case is, rather than specifying a DEX address, they specified a token address, and rather than using a swap function, they used a transfer function. This effectively allowed the hacker to manipulate Dexable into transferring its users' tokens directly to the hacker's account. And this was possible because the users approved Dexable to transfer their tokens. A very similar hack happened on SushiSwap this year. In this case, the hacker was able to pass an invalid pool contract into the SushiSwap router function, and this allowed them to take advantage of approvals given to this router by various users, and they were able to perform a very similar hack to the Dexable hack. Now, these types of vulnerabilities can be prevented by performing very strict validation on these types of parameters, these external contract addresses and call data. And you can also consider redesigning the protocol so that such flexible parameters are not required. This would greatly reduce the attack surface. So another huge trend we've seen in 2023 is the rise of read-only reentrancy hacks, and we've seen at least 4 major hacks happen due to this vulnerability. The first one that happened this year was on the Midas protocol. And so Midas is a lending protocol which allows Curve LP tokens as collateral. And the way it determines the price of this collateral token is it uses this get virtual price function on the Curve pool. The get virtual price function depends on the total supply of the LP token. So the attacker removes a large amount of liquidity from Curve, and then this results in a large amount of LP tokens being burned, resulting in the supply decreasing considerably. So this in turn affects the value returned by the get virtual price function, which is now going to return a very inflated price. And when the callback function on the attack contract is called, it's able to take this huge loan from Midas, which Midas allows because it thinks that the attack contract has a lot more collateral value than it really does. And there's been a couple of variations of this style of hack on dForce, which use liquidation instead of borrowing, and then on Sentiment and Sturdy, which use balancer LP tokens instead of Curve LP tokens. Now, this type of vulnerability can be prevented by using some type of function with a reentrancy guard before retrieving the price, or by using a library such as Balancer's Vault Reentrancy lib. Also, generally speaking, we should be really cautious with LP token price calculations. So this brings us to the end. Thank you so much for listening.
Thanks for the talk.